Hello, my dear students. Let us discuss about the next topic, control of seepage in the dam. One of the basic requirements for the design of an earth or a rock-filled dam is to ensure safety against internal erosion, piping, and excessive pore pressure in the dam. A suitably designed drainage system is therefore essential to satisfy these requirements. The seepage of reservoir water through the body of the dam or at the interfaces of the dam with the foundation or abutments creates two main problems. Apart from causing excessive water loss and thereby reducing usable storage of reservoir. The first one is seepage force causing excessive water loss, and second one is piping. So these are the main two problems of the dam. In spite of taking all measures in design as well as construction to minimize seepage, it does take place either through the body of the dam or at interfaces. Whatever may be quantum of seepage, if it is not safely drained away from the toe of the embankment dam into nearby drainage, valley, etc., it may lead to failure or heavy damage to the embankment by way of slips of slopes and or development of internal erosion leading to formation of sinkholes, boiling, settlements, etc. Besides creating unfriendly environment on downstream faces and areas of embankment dams. The design is mostly governed by type and permeability of base materials as well as filter materials, water depth in reservoir, topographical features of dam, site, etc. The conventional types of seepage control and drainage features generally adopted for the embankment dam are as follows. The first one is impervious core, second one is inclined or vertical filter with horizontal filter, network of inner longitudinal drain and cross drains, horizontal filter, transition zones and transition filters, intermediate filters, rock toe and toe drain. So let us discuss one by one. These are the main drainage system may comprise of either one or combination of more than one of these drainage features. The first one is inclined or vertical filter. Inclined or vertical filter abutting downstream face or downstream transition zone is provided to collect seepage emerging out of pore or transition zone and thereby keeping the downstream shell relatively dry. In the eventuality of hydraulic fracturing of the impervious core, it prevents the failure of dam by piping. Second one is horizontal filter. It collects the seepage from the inclined or vertical filter or from the body of the dam in the absence of inclined or vertical filter and carries it to toe drain. It also collects seepage from the foundation and minimizes possibility of piping along the dam seat. Next is inner longitudinal and inner cross drains. When the filter material is not available in the required quantity at reasonable cost, a network of inner longitudinal and inner cross drains is preferred to inclined or vertical filters and horizontal filters. This type of drainage feature is generally adopted for small dams where the quantity of seepage to be drained away is comparatively small. Next, transition zones and transition filters. Transition zones or filters in earth and rock-filled dams in the upstream and downstream shells are necessary when the specified gradation criteria is not satisfied between two adjacent zones. When such zones or filters are placed on either side of the impervious core, they help to minimize failure by internal piping cracking, etc. that may develop in the core or by migration of fines from the core material. The filtered material uh, the filter material used for drainage system shall satisfy the following criteria. The first one is filter materials shall be more pervious than the base materials. Filter materials shall be of such gradation that particles of base material do not totally migrate through to clog the voids in the filter material, and filter material should help in formation of natural graded layers in the zone of base soil adjacent to filter by readjustment of particles. So these are about transition zones and transition filters. Next is horizontal filters at intermediate levels. Horizontal filter layers at intermediate levels are sometimes provided in upstream and downstream shells to reduce pore pressures during construction and sudden drawdown condition, and also after prolonged rainfall. The filter layers should be extended up to the outer slopes of the embankment so as to drain out the collected water. These filter layers should not be connected with incline or vertical filters. A minimum space of 2 meters or more should be kept between the face of incline or vertical filter and downstream intermediate filter. The material of the filter layer should be protected at exposed faces. Next is rock toe. The principal function of rock toe is to provide drainage. It also protects the lower part of the downstream slope of the earth dam from tailwater erosion. Rock available from compulsory excavation may be used in construction of the rock toe, where this is not possible and transportation of rock is prohibitively costly. Conventional pitching should be used for protecting the downstream toe of the dam. The top level of the rock toe or pitching should be kept above the maximum tailwater level. In the reach where the ground level at the dam toe is above the maximum tailwater level, only conventional pitching should be adopted. The top of the such pitching should be kept 1 meter above the top of the horizontal filter or strip level, whichever is higher. A zone of coarse filter should be introduced between the rock fill or pitching and the fine filter. This and also a combination of partial rock toe and pitching may also be considered to affect economy. These are about rock toe. Next type is toe drain. Toe drain is provided at the downstream toe of the earth or rockfill dam to collect seepage from the horizontal filter or inner cross drains through the foundation as well as the rainwater falling on the face of the dam by suitable means according to site conditions. Additional longitudinal drain and cross drains connected with the toe drain are sometimes provided where outfall conditions are poor. It is preferable to provide the toe drain outside the toe of a rock toe to facilitate visual inspection. The section of the toe drain should be adequate for carrying total seepage from the dam, the foundation and the expected rain. The above measures required for seepage control within the body of an embankment dam may be had from the Bureau of Indian Standard Code IS 9429 1999 Drainage System for Earth and Rockfill Dams Code of Practice. So these are some of the methods of controlling the seepage in the dam, that is impervious core, inclined or vertical filter with horizontal filter, network of inner longitudinal drain and cross drains, horizontal filter, transition zones or transition filters, intermediate filters, rock toe and toe drain. I hope all of you understood. Thank you.